Hello everyone, welcome to the channel. In this video we will learn about some special sets, types of sets, equal sets and equivalent sets. First we go to the special sets, some special sets. We have already learnt about the representation of sets and their elements. Now here first one we take as the set of natural numbers. Set of natural numbers. We know all the natural numbers are 1, 2, 3, 4 and so on. This set is represented by capital N. If somewhere capital N is written means this is a set of natural numbers and its elements are represented by small n. Second set we have is set of whole numbers. We have already learnt in the real numbers or number system what are whole numbers. Whole numbers are starting with 0, that is 0, 1, 2, 3 and so on. This is represented by capital W. Number 3 we have set of integers. We know all negative and positive whole numbers are known as integers. Integers are represented like this, that is starting from minus infinity, minus 2, minus 1, 0, 1, 2 and continue in the positive direction. This is represented by capital Z. Number 4 we have set of rational numbers. We all know rational numbers are represented by P upon Q. So we are representing this in the set builder form. X equal to P upon Q, where Q is not equal to 0 and P and Q are any integers. This set of rational numbers is represented by Q. Next we have set of real numbers. We know all rational and irrational numbers are known as real numbers. So here we can write x such that x is a rational or irrational number. This set of real numbers is represented by R. Next set we have is set of complex numbers. Complex numbers, as we know, is a combination of a real and imaginary number. We represent it as a plus iota b, where a and b are two real numbers. So we represent this also in the set builder form, that is x such that x is equal to a plus iota b, where a and b are any real numbers. And this is represented by capital C. Now after these we are going to represent either positive numbers or negative numbers. Like if we represent set of positive real numbers, that will be represented by R plus, or sometimes we write it as R plus. Next is set of negative real numbers. This can be represented as R minus or R minus. Next is set of positive integers. This we represent by Z plus or Z plus. Then we have set of negative integers that will be represented by z minus or z minus. And then we have set of positive rational numbers that can be represented as q plus or q plus. And the last one is set of negative rational numbers that is represented by q minus or q minus. So these are some of the special sets we have, and in case we want to represent only the positive part of it or negative part of it, that can be represented like this. Now we'll learn about types of sets. The types of sets according to the number of elements in them are: number one, finite set. What is a finite set? Name itself tells. If it has definite number of elements. A set containing definite number of elements is a finite set. Like we have a set A, in which elements are 1, 2, 3, 4, 5. This is a finite set because the number of elements in this is 5. Second example we can have, suppose we have a set B, x such that x is a natural number and x is less than equal to 6. It means this can be written in the roster form having the elements 1, 2, 3, 4, 5 and 6. There are only 6 elements, and that's why it is also a finite set. We can have some more, like we have a set C. Suppose it is having the elements A, E, I, O, U. The vowels, these are also 5. So this is also a finite set. Second type we have infinite sets. What is infinite set? Here also the name tells that it contains infinite number of elements. Contains infinite number of elements. For example, all these sets which we have learned just now, set of natural numbers, set of whole numbers, set of integers, they are all infinite sets. We can have some more examples. Suppose we have a set P, that is x such that x is equal to 2n plus 1, where n is a natural number, n belongs to n, means n is an element of n, that is set of natural numbers. If we write it in roster form, do we find this is 1 plus 2, that is 3, 3, 5, 7. Like this we are getting all odd numbers greater than or equal to 3. So this is also containing infinite number of elements, and that's why it is an infinite set. We can have one more example. Suppose Q. Q is suppose having all multiples of 3, that is 3, 6, 9 and so on. This can also be written in the set builder form, x such that x is equal to 3n, where n belongs to n. N is an element of capital N, it means this is a natural number, and the multiples of natural number, that is by 3, They are 3, 6, 9 and so. So this is also an infinite set. We have to remember when these are infinite sets and we are writing in the roster form, we write some of the numbers like 3 numbers we are writing and then we put 3 dots. That shows that this is continuing till infinity. Next type we have is singleton set. What is a singleton set? Any set containing only one element. A set containing only one element is a singleton set. For example, suppose we have a set A having only element 3. This is a singleton set. Another example we may have, suppose this is given in the set builder form, it is x such that x is the smallest prime number. We know smallest prime number is 2. So this will contain only one element, that is 2. So it is also a singleton set. Now the next type we have is an empty set. We also call it null set, or we call it void set. Here the name itself tells empty, null, void. It means there is nothing in this. In sets we say a set containing no element. So we say it contains no element. So any set having no element in it is an empty set. For example, we have, suppose a set A x such that x is a natural number and x is less than 5 and x is greater than 8. Do we have any natural number which is less than 5 and also greater than 8? There is no natural number. It means this is an empty set. Empty set we represent by phi. This is phi. Or we represent it by a curly bracket with no element in it. Empty curly bracket. Please remember, these are the only notations for it. We can have one more example. Set B x such that x is a truthful man who always speaks lie. Can we have any man who is always speaking lie and he is truthful man? No. So this is also an empty set phi. Please remember that it is always represented by phi only or a curly bracket. Sometimes what we find, the question is given like this, a curly bracket inside a curly bracket. And also it is given sometimes phi inside a curly bracket. These are null sets inside the curly bracket. It means the null set is an element of it. Don't get confused. These are not null sets. So these two are not empty set or null sets. Null set is only when there is no element in the curly bracket, no element in the set. It is represented by these two ways only. After learning about the types of sets, we learn about equivalent sets and equal sets. What are equivalent sets? Actually, any of the sets having equal number of elements, elements may not be same, elements may be different, but number of elements are equal in them, then we say that they are equivalent sets. So we say the sets containing equal number of elements are equivalent sets. For example, suppose we have a set A. The elements in this are 1, 2, 3, 4. Another set we have B. In this elements are A, B, C, D. Both are having 4 elements, and that's why A and B are equivalent sets. Second example we may have, suppose we have a set P, X such that X is a letter of word pen. Another we have Q, X such that X is a letter of word cool. If we write them in roster form, when we write in roster form, the elements are P, E and N. If we write this in the roster form, we are finding here C, O and L. Do we find that both are having equal number of elements? They are 3, and that's why they are equivalent sets. Now coming to equal sets. Equal sets are having the same elements. So we can also define it like this. Sets A and B are equal if every element of A lies in B and every element of B lies in A. It means they are having equal number of elements as well as same elements. Then we write them as A equal to B. Suppose we have a set A, in this the elements are 1, 2, 3, 4. Another we have set B, in this the elements are 3, 4, 1, 2. Order may be different but the elements are same. And that's why you say A is equal to B. One more example we may have, suppose we have a set X. X such that X is a letter of word tool. Another set we have Y, X such that X is a letter of word lot. When we write this in roster form, we are finding the elements in this are T, O and L because the element O cannot be repeated. In this also we are finding the same, that is L, O, T. Elements are same, and that's why we say X is equal to Y. Then we can say that the elements are same and number of elements are also equal, therefore the sets are equal. From these two you can make out very well. These two sets which are equal, they are also having equal number of elements. So can we say that they are equivalent? Yes, all equal sets are equivalent because they contain equal number of elements. But can we say that these equivalent sets are also equal? Not necessary. And that's why we have to remember one thing, that all equal sets are equivalent, but all equivalent sets are not equal. Very important point, please remember this. All equal sets are equivalent, but all equivalent sets are not necessarily equal. In the next video, we will be learning about subsets of a set and the universal set. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.